Hi again. So this is 22.4, which is hydrocarbon rings. So we've been looking at straight molecules, branched molecules. Now we're getting into a point where the carbons can actually form a ring with each other. And so if we look at the hydrocarbon rings section of your notes packet, you're going to see cycloalkane. This actually has two prefixes in it. Cyclo means ring. Alk, we've seen that one before, means hydrocarbon. And ane means all single bonds. So cycloalkanes are rings of carbons and hydrogens with all single bonds. The ring part is made out of carbon, and then there would be hydrogens attached to each of these carbons to fill up the 4-bond requirement to make carbon stable. So each of these carbons would also have 2 hydrogens attached to it in those structures. Now this is a carbon skeleton for cyclopropane. Prop is 3 carbons, ane is single bonds, cyclo is ring, so cyclopropane. Cyclobutane for 4 carbons, cyclopentane for 5 carbons, and we could keep going. Cyclohexane, cycloheptane, cyclooctane, etc. If you want to draw a skeleton structure or the line angle structure for these, you can just draw the shape. Okay, so this is cyclobutane, that's cyclopropane. A pentagon would be cyclopentane, a hexagon, cyclohexane, etc. Okay. That gets us into the next part of 22.4, which is aromatic versus aliphatic. Aromatic means it has benzene in it, and aliphatic means it doesn't have benzene in it. But it's more specific than that. Now, the book says any compound not classified as aromatic, but really it should be any organic compound not classified as aromatic. So it still has to be organic, but no benzene in it. And the book also says has benzene or a structure with bonding similar to benzene. And I'm going to talk about that in a minute, okay? So benzene is 6 carbons with 6 hydrogens, and it's alternating single, double, single, double, single, double bonds in that ring, okay? So benzene is 6 carbons with alternating single and double bonds in a ring form. And if it's by itself, it has those 6 hydrogens on the outside. And you can draw it like this, a hexagon for the 6 carbons, and then you change 3 of the sides to double bonds. Doesn't matter which 3. If you remember back to chapter 8 when we were drawing structures, if something can have double bonds in different places, then you can have resonance structures. So really, benzene has 2 resonance structures. One with the double bonds here, 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 and then one where the double bonds would be here, here, and here. And those would be the 2 resonance structures. So to make our lives a little bit easier, remember resonance means it's really kind of a blend of this one and the other one. It's not really single doubles. It's kind of, the double bonds are in motion is one way you could think of it, or more like 1.5 bonds in all of these locations. And so one way that we draw that in benzene is we just draw a circle to show that. Okay, so a circle inside a ring means alternating single and double bonds, but in reality, it's a resonance structure. Okay, for aromatic, if it has benzene or a structure like benzene, it's aromatic. And the only other one that I can think of is an octane, so an 8-carbon ring that has alternating single and double. You do have to have the alternating single double all the way through your compound, through the ring to be aromatic. Okay, there is a section on naming compounds with benzene. Okay, and there's 2 ways that benzene can appear in a complicated compound. It can be benzene with substituents, so benzene is your parent and it has branches coming off of it, in which case we're going to name this like benzene is the parent, okay? So this is my branch. It only has 1 carbon because there's only 1 point. So a single carbon is meth, branch is YL. So methyl, this is a methyl branch, and it's attached to a benzene. So this is methyl benzene. Methyl benzene. Parent name is benzene. Methyl is the branch coming off of it. If you wanted to add a location, you can. On this one, we don't need it because there's only 1 branch. So no matter where I put it, it's going to be on carbon number 1 because we number the parent so that the branch has the lowest possible number location. But this one, I have 2 branches. So I need to number my benzene so that those 2 branches have the lowest possible numbers. And we prioritize the longest branch. So this is going to be my carbon number 1. If I were to number it this way, this would end up being carbon number 5. But if I number it this way, it's carbon number 3. So that's the direction we want to go to give the priority and to get the lowest numbers possible. This branch has 2 carbons, 1, 2, so that's an ethyl. Okay, YL is branch, F is 2 carbons. This one only has 1 carbon, so it's a methyl. And when we name branches, we go alphabetical order. Okay, so 1 ethyl, 3 methyl, benzene. 1 ethyl, 3 methyl, benzene. 1 ethyl, 3 methyl, benzene. Okay, so that's just a couple of examples of benzene that have branches coming off of it. Now, when benzene is the branch, benzene as the substituent, we have a chain, and then we have benzene attached to that chain. Okay, so if we look at this, this kind of looks like benzene with a branch, but then the branch has a branch. We don't get that complicated. There's only one branch, okay? So this is my parent. This short molecule here is my parent, and benzene is attached to it as a branch. This long one is my parent, and benzene is attached to it as a branch. When benzene is the branch, it is called phenyl. Phen, P-H-E-N, is a new prefix, a new prefix. That prefix means benzene. And that suffix right there, YL, still means branch. So phenyl is a benzene branch, okay? In this parent molecule, I have 1, 2, 3, 4 carbons, all single bonds, so that's butane. And remember, we number the parent so that the branch is attached to the lowest possible number. So that's going to be carbon number 2. So 2-phenyl butane. 2-phenyl butane. Okay, 2-phenyl butane. This one, I have 1, 2, 3, 4, 5, 6, 7, 8 carbons, all single bonds. That's octane. And if I were to number this, it's closer to this end. So 1, 2, 3, 4 is where my branch is. So this one is 4-phenyl octane. 4-phenyl octane. Okay, so there we have benzene with branches and benzene as the branch, 2 different naming systems. Okay, the final piece of that section was a question where we compare these 4 compounds and whether they are aliphatic, aromatic, saturated, or unsaturated. Okay, so hexane, I'm just going to draw the skeleton here real quick. 1, 2, 3, 4, 5, 6. 6 for hex. ANE is all single bonds, so there's hexane. Okay, 1-hexene, I'm going to go ahead and 1, 2, 3, 4, 5, 6, but the ENE, that suffix right there, is going to be a double bond. And I put it right here because 1 tells me that it's after carbon number 1. Cyclohexane. Cyclo is a ring. Hex is 6 carbons. Ane is all single bonds. So I'm just going to draw a hexagon as best as I can there. That's cyclohexane. And then benzene is also 6 carbons in a ring, but it's a very special type of substance. It has alternating single and double bonds. Okay. Okay, aliphatic, aromatic. Remember, aromatic has a benzene or a structure very similar to benzene. So it has to have alternating single and double bonds in order to fit that qualification and in a ring. Okay. So benzene is aromatic. The other 3 are all aliphatic. Okay. All right. That's those 2 columns done. Saturated versus unsaturated. Remember, saturated means full. And in organic chemistry with hydrocarbons, saturated means full of hydrogen. And that means all single bonds. Okay, so hexane is absolutely saturated. Hexene has a double bond, so it's absolutely unsaturated. Benzene has double bonds, unsaturated. Okay, now cyclohexane, I would take either answer, and here's why. If we're thinking about single bonds, yep, there we go, saturated, okay? But because I turned it into a ring instead of hexane, it actually lost 2 hydrogens by turning it into a ring. And so if you argued that this was unsaturated, I would take that as well, as long as you had that explanation attached to it. Okay, so that is 22.4. Next video will be 22.5.